A very good afternoon to ladies and gentlemen. Thank you for coming to our today's webinar series. And I'm Eunice here, so the module coordinator for safety in process plant design and also the program director for chemical engineering. And today with us, we have Mr. Vincent Call, who is our alumni who graduates a few years ago. And now he is currently the head of department for process engineering department and site lean representative. So without further ado, I'll pass the sessions and the host to Mr. Vincent.
Okay, thanks, Dr. Eunice. So good evening, everyone. So I think you can hear my voice clearly. Yeah? Okay. So today I would like to talk to you guys about the topic on introduction to manufacturing excellence for specific on the area of chemical manufacturing industry. So actually, I've given this talk I think a month ago in another platform for under the engineering institution platform. So today I will share a similar experience with you guys as well, but I will be a bit more focused for the fresh graduate, especially those that are coming up to the industry very soon. And also I hear that some of you guys are going to do your industrial placement soon as well. So without further ado, let me proceed. Okay, so before I started to present the content, maybe let me introduce myself a bit. So currently I'm the head of department for the process engineering department, and also I'm heading the lean department at Henkel Shah Alam in adhesive technology. So my industrial experience will be more on bulk chemical production, especially on blending and mixing. So I have been past few industrial standard. So for example, I'm the internal auditor for 9001 and also the IMS 9001, 40,000 and 45,000. I'm also a level 2, 3 practitioner. I've won several competition, both external and also internal from my job for Kaizen competition, MyTrees, and also the simple SOMCHE. So currently I'm also serving as a core member for the IMCDD committee. Okay, so today agenda will be focusing on this 3 topic. Actually, sorry, I forgot to remove the fourth. It will be focusing on the 3 topic. So first will be the introduction of manufacturing excellence. So to tell you what is manufacturing excellence, followed by the 2 key principles that you need to understand in order to achieve manufacturing excellence. So the first will be the Lean principle, following by the hybrid combination of Lean and Six Sigma. Okay, so wait, let me hide this a bit. Okay, yes. Okay, so what is manufacturing excellence? So as an engineer, we have to know that whatever we want to achieve something, we need to ensure it can be measured. If that thing cannot be measured, it cannot be achieved. So same for manufacturing excellence. So what do we need? What is the requirement to achieve manufacturing excellence? First will be the better product quality. So in order to achieve it, what do we need? How do we measure it? So normally in the industry standard, we will measure it by customer complaint or what we call CCMS, customer complaint management system, under that platform, or what we call internal rejection rate. So the other one will be better processes and value. So how do you measure it? So this one will be on the OEE, overall equipment efficiency, and also your monthly capacity, all those stuff. So following by that will be faster service response, processing, and delivery. So same as I believe a lot of people purchase their thing in the Double 11. So you want as an end user, you are looking for faster service response. So how do you measure this thing? So under the Lean principle, normally we will measure it using cycle time, tech time, or the production lead time. So these 3 times actually they are measuring a different phase of a delivery process. So the last and the most important will be the cost. So you want to ensure that you can stand in the market as long as possible when you have a very low cost. You can control a cost, so cheaper to operate. So in order to achieve it, how do you measure? Productivity, your capacity over your full-time employee, and your full processing cost, FPC, your unit processing cost, UPC so on. Okay. So now we come to Lean principle. So just now we mentioned that in order to achieve manufacturing excellence, so we have to use certain principles. So Lean principle will be the most commonly used in the industry nowadays. So lean was first used in, actually it was founded by Ford. It was founded by Ford. Then later on, it was popularized by Toyota. So I believe regardless what factory you go in, what industry you go in, lean will be a common concept, will be approached lah. So in the lean core principle, so the lean actually, if you simplify is to minimize waste and also maximize product value that the customer is paying for. So in the very short sentences, it gives out the three key elements. First, you have to minimize waste. Secondly, you have to maximize the value, your product value, which the last and the most important is the customer is paying for. So if you are maximizing or minimizing waste that is not the customer expected, actually you are just wasting your time. So for lean, you have to ensure that what you're doing is what customer is paying for. So by minimizing waste, we have to first ask ourselves, how do we identify the waste? So Teamwood is an acronym for this 3, 4, 6, 7. This 7 item. So these 7 item include everything that you can find in the production waste, in the process waste. Not necessarily a production environment. It can be any process, for example, banking, or maybe even a transaction process. So you can identify this kind of waste using first is transportation. Like I mentioned earlier, transportation is definitely a waste. You will have a waste of delivering this thing from one station to another station. For example, if you order a thing from the online e-commerce platform, actually they are having this kind of issue currently of having the waste to deliver one item to one station before delivered to your house. Is a waste over there. Inventory. So inventory and transportation, they are correlated to each other. So inventory is also a type of waste. If you need to keep a lot of stock, for chemical industry is will be mostly on raw mat because especially in Malaysia or some of the country which you rely on imported raw mat, inventory will be quite challenging to handle. So following by that will be on motion. So motion, I think, is very straightforward. When you are doing a process, you are doing certain action, your motion will create a lot of wastes that you can further lean it, or minimize the waste lah. Then of course the other one is waiting. For chemical industry, waiting is a type of waste as well, because for a lot of, for example, for reaction, you need to have a process of heating up and also waiting to cool down before you process to the next step. So this kind of waiting is is a type of wastes. Then of course, following by overproduction, over-processing. So you product processing, then you result in inventory, you will result in waiting and motion those days. And then the last will be on defect and rework lah. So it's not uncommon to say that in chemical industry, it's very, very common to have rework due to a lot of factors, because you have so many formulas, so many recipe. Some of the recipe will be quite tricky and very, very sensitive to the process parameter if you do anything wrong. So rework is somewhat similar. So how are you going to do just right first time, and how do you reduce rework? Yeah, this is another way for you to minimize waste. Okay, so I will use some case study. So this few case study will be the very, very common process that you can see in the chemical industry, regardless what kind of industry you are going in. Since I was working in the mixing and blending industry and biochemical, so I will use this kind of example lah. But I think you will find a similar process in the other chemical industry as well. So the first will be a loading bay. So for chemical process, you need to load a powder, rubber, or solid item inside. So most of the time, it will be more economical sounds feasible to just use a paper to load it. Okay, so in this case, the process actually is doing grinding. So you want to grind the powder into a finer molecule. So the observation what you saw here is loading the raw mat. So what type of waste can you identify here using the acronym Teamwood? So the first will be the motion. Definitely you see they have to pile out the okay, so this kind of bag, what we call is a 25 kg bulk bag lah. So the standard weight actually is 25 kg. So you can see they have to turn back and then move it. Okay, this will be a certain waste for it. Then following by what? Inventory. So this is the common issue that they have when they are doing loading, because most of the time, if you're, let's say, saying a 13 ton or 4 ton, 5 ton mixing process, you need a lot of bag, So how are you going to handle this kind of inventory at site? Then of course, transportation, how they're going to transport the raw material to your site and then unload it back, all those stuff. This will be several ways we see. So after you identify these kind of ways, you can come up with a certain improvement idea saying, maybe I have a silo. I maybe for certain powder that is very commonly run, I use a big silo and then use a blower to blow it into the grinding vessel or how. So this can be certain idea, or maybe you can use what we call a stacker. So the stacker actually can help to lift up the item into a ergonomical height. This can reduce the waste in motion as well. So for every waste you identify, right, you have to identify their cycle time at the same time, because if you cannot identify their cycle time, you cannot measure your improvement. So you have to always ensure that after you identify your waste time, your waste category, also identify the cycle time or the corresponding value that you can measure later on. Okay, so okay, the other one will be on filling and packing base. So this will be very, very common in all chemical industry. So in chemical industry, regardless you are packing in liquid form, you're packing in powder form, solid or liquid form. So in this case, we are talking about in liquid form. So this is a IBC tank, what we call is IBC tank. So the IBC or tube bin normally come with a 1,000 or 1,200 kg weight. So so the process we saw, they are doing filling process. So the observation here is they are filling finished good. So for chemical industry, you have semi-finished good, you have finished good, or sometimes your raw material you have to cut into small packing size, what we call loose bag. So here what we can see what is the type of waste. Of course, you will see a similar situation as the charging from the previous slide. They're having a lot of inventory for their packaging material, which is the IBC tank. So you can see the IBC tank inventory is a type of waste we can see. And of course, what is the motion? So you rely on people to fill it out and then turn around. So this is a type of waste as well for motion. Of course, transportation of transporting your tube bin to the station. So this is type of waste. So what will be the improvement idea? So the improvement idea will be, of course, you can rely on the semi-filling. So if you have a semi-filling, actually, you don't need to rely on the people to fill it and then on and off the filling station. So it will be much more automatic lah. And also, maybe you can look for other method to pack item. For some of the fast-moving consumer good industry, especially the F&B industry as well, if let's say you have an agreement with your customer, so maybe you can have an agreement with that saying that I pack the item in the what we call straight away in the tank. So if you deliver to them in a tank, it's much more easier to deliver in just IBC. I mean, when I mention a tank, it's like it's a big tank lah. ISO tank, yeah, ISO tank. You can deliver to them in the ISO tank. So if you deliver to them in the ISO tank, which is about 13,000 metric ton, yeah, definitely it will be save much more time than just pack one by one. Yeah, this can be one of the thing you can use to improve your packing process. So same, you have to identify your cycle time from this as well in order to justify your improvement idea. Okay, so the last one will be holding tank. So what is the process? Adjustment, observation adjustment. So for chemical process industry, it's very, very common to have your process turn from one batch to one batch if it's not a continuous process, if it's a batch operation. So I believe all the chemical engineering student is quite familiar with this, but maybe not see it in person. So if it's a batch operation, you have to turn from one tank to one tank. Even in the continuous process, it's also case by case basis, because adjustment is needed for certain chemical product which is very very sensitive, I can say, or it requires a lot of adjustment in order to achieve a very tight QC scope, tight cage scope, the range. Maybe they need the viscosity to be in this range. They need they need to ensure that the color reading to delta E to be in this range. So this kind of adjustment is needed. And also the holding tank can be used for other process like cooling down it before you proceed to another phase, all those stuff. So what will be the waste? So the waste of course very clear is the weighting. So if you have holding tank, for sure you have a waiting time. So how are you going to reduce the waiting time is one challenges. Of course, the other one is the transportation. So for transportation is from the holding tank, eventually you have to transfer to another places. It can be you transfer to packing station, it can be you transfer to another mixer, rector, all those stuff. So how are you going to reduce these processes? These wastes is depend on your improvement idea as well lah. So same as the previous one, identify your cycle time before you jump into the improvement idea phase. Okay, so what will be another key principle of Lean? What will be a key item for Lean principle? So this will what we call a value stream. So you have to ensure that you value stream the process that transport the input resources into your output value that favored by the customer. So again, emphasize on it, favored by the customer. So normally how we do this is we create a value stream mapping. So value stream map is a type of information flow that somehow all the action that require for a product to be produced or even a service. So it shows the end-to-end process for the whole item to be produced. So normally what are the major item you needed for the VSM? It will be, of course, CI workshop. So CI workshop is what we call a continual improvement workshop. So you need to have a workshop, invite all the stakeholder, the related stakeholder to come in to give their opinion. So this will involve a lot of party. It will be coming, you will in customer service, supply chain people, network supply chain. If you can further break down into raw network planning, purchasing, all those stuff, all those department, and then production, process, maintenance, project team. So it depends on the level of your project. It can be go up, show up to even higher level to a sub-regional, regional, or even a APAC, or even a global scale. It depends how big is your project. So a cross-function participant is a must in order to value stream a process. Then later on will be a swim lane diagram, spaghetti diagram. Inventory data is if you are looking to full scale, fully involve everything to look it, even including the supply chain part. So you can do inventory data as well to include it in. And the other one, what we call a CPOC, supplier input, produce output, and customer. Later on, I will show you as an example. And then also the value stream mapping of the current and then the future expected stage you're looking for. And then time analysis, KPI, KAI, breakdown, and also the action plan. So this will be a value stream mapping template. So a value stream map will include everything into a single page. You will include every part of your process from how you get your raw mat, how long you get a raw mat, to how much time you take your process, to how much time you take out, send to a customer, and how you're going to do a control. So the control normally we do is using what we call ERP, Enterprise Resource Planning software, like the one you hear very commonly, like SAP, M3, Lawson, this kind of software. Okay, the other one will be on CPOC. So CPOC is very clear. You have to identify who is your supplier and what is their input, and then what is the process, and then what will be the output, and who is the customer. So this one will help you to list out, to show you a very clear view on for this certain step, who will be in charge of what thing. So the supplier not necessary to be external, it can be internal. So it's very common to have internal supplier. For example, I received the purchasing order from customer service, and then the planning and the scheduler, for production team, they receive the production schedule from the scheduler. So this will be their supplier. So what will be the process and what will be their output? Yeah, this one, it depends on case by case basis lah. So the customer is the same. The customer not necessary to be the external customer. It can be the internal customer as well. For example, to scheduler, their customer is production team. So, and then same for production team, their customer will be the warehouse team, material management team. Okay, so the other one will be the swim lane diagram. So swim lane diagram basically is to show the flow. Is quite similar to value stream mapping, but in different way and then much more simplified. So swim lane diagram is to show the information flow. So you have to understand that how your information go through from what first stage to the end of the stage. especially for example, like how you process the order. So after your order come in, how will it turn? It will turn into a purchase order. So the purchase order, how will it turn into maybe a schedule. After the schedule, how will it turn into a warehousing slip, and then turn into something, the bill, invoice, all those stuff. So this is how the information flow. So the Streamline diagram is to display the information flow. The other one with spaghetti diagram. So spaghetti diagram taken from his name is to show the motion of how you achieve a certain process, what you do in a certain process. So we call it spaghetti diagram because after you drop the thing, the whole thing will be like a plate of spaghetti. So you have to understand that how you move one thing to another. So the reason of doing spaghetti diagram is to reduce the movement waste, is to focusing on the motion waste, the transportation waste, the movement waste. So spaghetti diagram, although it's a very simple tool, it's a very powerful tool. So it's especially important for area that is very small. It not only reduce up the transportation distance, it also at the same time help you to identify actually you have extra space. You can minimize the space you use and then extend the space you have. So spaghetti diagram has a particular function on this. Okay, so after I introduced to you how can we use value stream in the chemical industry environment. So I use a case study. So the process for this process is a grinding process. So the unit now we are seeing is called what we call a basket mill. So a basket mill is a type of grinder lah. You can see in the industry commonly maybe used for your use in F&B, in paint industry, in ink industry. So in here, what will be the internal supplier? So the internal supplier, it can be the pre-mixing station. So normally before you jump into the grinding process, you have to do pre-mixing. You have to pre-mix before you jump into. Or maybe for your process, you can straight away do grinding. Then your internal supplier will be very easy. Your internal supplier will be a scheduler. So the scheduler have to schedule everything to you, maybe then pass to the warehousing. So the warehousing can be your internal supplier in this sense lah. Then your external supplier, maybe the raw mat supplier, machine supplier, or some of the additive supplier are raw mat or item supplier. It depends. So who will be your customer? So after you do grinding, if you have a further process, what we call let down process, then let down station will be your customer in this sense. External customer, of course, is your client or even your end user. So you have to identify what is the process step when you're doing this grinding process. You need to start the machine, you need to do earth bonding, you need to charge in your tank, your movable tank, then you have to start the process. Some of time you have to do trial, and then you have to do, so for batch process, sometimes it's not necessarily just one shot. Maybe you have to do 2 pass, 3 pass of grinding process in order to make it more efficient, shorten the time. Yeah, this will be the process that we have to identify to very clear like every single step you need to do to achieve this process. So what will be the lead time? Lead time meaning that the total time taken for you to achieve this, not just the process time, not just the process second, it's a total lead time from the beginning you get your item to the end you send to a customer. What will be the total lead time? And then also you have to identify what will be your travel distance. For example, they have to travel they get the sample to the mixer, then they have to go back to the panel, then come and fall back and fall back and fall. This will be a very common travel distance. And then some is like you sending a raw mat in, sending a raw mat out. Yeah, this will be a type of travel distance. So the other one will be the KPI. So what type of key performance index you're looking for? Okay, so like I mentioned at the beginning, to improve, you need to be able to measure. So the KPI will be your KPI. So your takt time. Takt time is takt time actually is coming from a German word. So takt time meaning that is the time that required by the customer for a single product lah. So you have to identify what will be a takt time, what will be your cycle time, what will be your capacity, production capacity. This will be your KPI. So KAI is another term what we call key activity index. So for KAI, you have to identify what type of activity is this? Is it a motion activity? Is it a transportation activity? Yeah. And then if you identify a KI, maybe you can see which activity actually you can further reduce. You can see in this area actually we have a 20 KI and it's all within the motion. So you can see how can we reduce this kind of KI lah. Okay, next will be another lean principle. So what we call pull system. So pull meaning that you are doing a replenishment from a process. So it should be triggered by a real consumption and respond to what we call VOC, voice of the customer. And then you only produce quantity and quality, which quality-wise is what we call CTQ, critical to quality. So to meet customer demand. So the pull system, in order for it to be effective, you have to promote the release of real consumption information and trigger the replacement of your finished good, your WIP, work in process item, your raw mat, and then also your packing material. So when we try to pull something, we have to ensure that we are pulling it in the actual sense. We are not pulling it with the sense of just pulling, because if you purposely pull for example, you push the production to produce more, but actually you do not have that demand, so you are overproduction. So it's a type of waste, right? So you are overproduction. So pull system, actually you have to trigger it based on the real consumption and then correspond to the voice of the customer, meaning that the customer demand. And also CTQ, critical to quality, which is correspond to customer demand as well, meaning that this type of QC spec is demand by the customer, not demand by you yourself. It is demand by the customer. Okay, so what will happen? What will be the scenario if you overpush? So if you overpush, of course, you will cause us a lot of inventory space to demand to rise. So the space is fixed already. If you keep pushing, your space will eventually fill up. So we will have issue on that. Increase is OSMI. So OSMI, what we call obsolete stock. So if you have a lot of OSMI, you have a lot of aging stock, then you will create a lot of waste, and waste not only in terms of process, you are causing waste in monetary value, which is very, very huge and significant. So you have to ensure that you don't overproduce. Because most of the chemical product, they will have an expiry date, mostly half years, 1 year. Very seldom to more than 2 years lah. So you have to ensure that you don't create those kind of obsolete stock lah. And then poor asset utilization. So since you're overpush, maybe you overpush for a certain product which is not in high demand, you loses the asset utility for another product which has a high demand. So you causes a poor asset utilization performance. The one will be increased difficulty in looking for parts. So if your inventory rise out, you are forced to stock the item very near to each other in a very squeezy place. So you are increase the difficulty in looking for part as well. Of course, you increase stock count difficulty. So when you're doing an annual stock count, it will be very tough because you are increasing the inventory. So at the same time, you increase moving activity because you have to do more movement. You create more inventory. You have to move in. You have to do RM movement. You have to do semi-finished good movement. Yeah. Then the push example, what we call is make to order. So MTO is a term lah. Normally they use it for when they do a certain for the supply chain. So for some of the item you order it when you in demand. You order it when you already have an agreement lah. You make to order lah. Okay, so the other one will be overpull. Overpull, what will happen if you overpull something? So first of all, you will increase in the scrap percentage and also the cost, of course. Then second of all is you will increase nervousness in the production. So you keep pulling them. So you eventually make them very tense. So the other one will be increased difficulty in planning and production scheduling because they cannot follow the forecast anymore. You are adding something in the middle of nowhere, so you will create this kind of issue. So at the same time, you delay customer delivery and also affect what we call ECSL, which is another metric to measure customer satisfactory level. So if you overpull, most of the time you will create defect. No doubt you will create defect, you will create issue, you will create incident. So it will eventually lead to delay in customer delivery if you don't do it properly. But since you're overpull, you're not doing it properly anymore. So the other one is affect forecast. So for every order, you have a forecast. So if you don't do it, if you overpull, you will definitely affect the accuracy. So another key example for pull is called MTS, make to stock. So there are few tools that we can use to establish a good pull system to to achieve what we want is reduce excess inventory and optimize excess utilization. So you can implement the VSM like what we mentioned earlier. Then you can identify the few key metric, like for example, days on hand, COH coverage on hand, throughput time, and then also you can use what we call Kanban. So Kanban is a pull signal to identify people what item to pull and what item to stop. Then you can implement Hejunka board to calculate what is the production rate now. You can do something what we call a supermarket. So the supermarket will be based on the principle of FIFO, first in, first out, one in principle to avoid you have excess stock. So the supermarket concept, like its name is derived from the supermarket situation what you saw now. So in the rack, you will only see them fill out the rack when the item is replenished. So how the item will be replenished is because people bought it. So this is based on real consumption. Of course, there are cases that people just take the item and then move into another rack or move to somewhere else. So you are causing the false information. So they have to have a setup to how do they identify and how do they resolve this kind of issue. Okay, so for pull system, we can use a case study. So from here, what you saw is a storage tank. So it's a storage process, then we call it like storage tank, holding tank. So what will be the product definition? So you have to see that what type of product you're putting inside. This will have a lot of consideration. Maybe this is a highly flammable product, or this product actually is a very highly oxidizing product. So you cannot store it in the non-exproof zone. You have to purposely store it in the exproof area. Or maybe this product is a food grade product. You cannot be contaminated with other places. So the definition of the product Then later on will be the location. So it's correlated to product definition as well. So what will be the location? And then what will be the stock level? Is it worth to have a storage holding tank, or the amount actually is justificable? You really need the storage tank for it. And then also how you're going to do visual control. So visual management is you have to put your label. Of course, first is for safety precaution. The other one is for the people to identify what is the item inside there. What will be the product code, item code, and then what will maybe even put out the date when you first charge in, when you first charge out. And then also FIFO, how are you going to do FIFO? First in, first out principle. Okay, so basically I have summarized the key principle from Lean. So just now what I say is like the pull system, the VS value stream principle, and also the teamwork. So following here will be on the hybrid between Lean and Six Sigma. So in all we call Lean Six Sigma. So what is Six Sigma? So Six Sigma is to provide a reliable and consistent product with focus on defect, variability, and voice of customer. So in general, they are talking about not more than 3.4 defects per million opportunity lah. So it's almost hit to the perfect. So imagine that if you're building a house, you have about 1 million opportunity that can fill, but you only have about a 3.4 defects per million opportunity. So which is almost close to perfect already. And the other one, Six Sigma principle in general, you are going to implement DMAIC. So define, measure, analyze, implement controls. Implement controls. So this is the key step you're going to go in. I believe in Taylor they have something called CDIO, somewhat similar but in a different nature Okay. Okay, so what is Lean principle I mentioned earlier is to eliminate non-value added activity, standardize work, eliminate waste, and then also make the layout and the equipment to be more flexible, more easy to access. So to make them to consolidate them together and the hybrid form is what we call Lean Six Sigma. So you use the mix of these two things to achieve a desired result a problem. So let's see if I have example behind. Okay, so let's say Six Sigma is okay. So in normal situation, you can first utilize Lean. Only when the issue come to very complex, then you have to use Six Sigma, because Six Sigma is very focusing on statistical analysis and statistical control. So for Lean, it's basically like what I mentioned earlier. You can reduce motion waste, you can reduce the waiting time, whatever that you can straight away identify, you can use Lean. It's very easy, straightforward. You just need a certain tools to help you to achieve that desired result. But for Six Sigma, it's mostly for issue that you don't know, you have no idea what is the root cause. You still cannot find the root cause. So maybe you need to have a Six Sigma to help you in this, and then to use the Six Sigma tools to guide you how to achieve a result, which rely on you have to ask for more data. in order to analyze the situation. Okay, so here I will give you a very good example in the chemical industry, how to utilize this Six Sigma principle. So what you see here is a reactor. So the process here, I assume is I make an assumption here is a polymerization process. So the product you're going to produce is a polyvinyl ether, so PVE. So what will be your target is to reduce cycle time, reduce foaming. So you can see in the Lean principle, what we can do in order to reduce cycle time, maybe we can reduce the movement using teamwork. We identify what will be the waste of the operator, we reduce it. And then the other one, we can use the value stream to value stream all the, how we deliver our raw material, how we discharge out our product, how we discharge the output from the reactor. Okay, so this kind of thing, you can use your Lean principle. So how about the Six Sigma methodology? How about reduce foaming? So if you're using Lean principle, it's very, very tough for you to identify what will be the cause of foaming causing inside the reactor. So you need to use Six Sigma methodology. You have to gather a lot of data. What will be, for example, 2-5 days data for your pressure inside of, your tank pressure, and then also your reactor temperature. And then if you, for example, in PV, you were charging VAM, the monomer, what will be your flow rate of your monomer, how fast, how slow is it, and also your stirring speed, and a lot of things you have to consider. The way you're charging your solvent, you're charging your raw mat, all these things. So using Six Sigma will be much more appropriate if you are focused, if you are looking to reduce this kind of issue, which is considered quite complex lah. Okay. Okay, so before I end the section, I give you what we hear from Henry Ford is, when everything seems going against you, remember that the airplane takes off against the wing, not with it. So same as when you implement this Lean Six Sigma principle in your work in the near future. So it's not going to be easy at the beginning, but nothing's work well has come easy lah. Okay. So thank you very much. So I think I will pass to Dr. Eunice.
Thank you, Vincent. Can you hear me? Because I just removed my mics and all that. Anyway, any questions from the floor? You all can unmute or you all can type in the chat box if you have any questions you want to ask Mr. Vincent. If no, then Vincent, would you like to share with our students here, because half of them are going for their internship in a month's time, in a month or two. So what is your advice to them if when they are about to enter the work environment?
Okay, so I assume most of them, they are currently studying in the chemical engineering discipline. So for industrial placement, I think you will, for engineer, if you are doing engineering placement, mostly you are just placed in several environment. One is of course the firm, what we call a design firm. So in the design firm, you will mostly stay in the office. Maybe once in a while, since you are doing maybe 3 months only, once in a while you will go back, you will go out to the site to do some site study. So in that sense, first of course is safety. So always be cautious. The environment is not safe, especially when you're doing firm. So the place maybe you go is a brownfield environment or greenfield environment, who knows, right? So be safe, wear the PPE, follow the PPE. And then if your firm is focusing on chemical industry process, ensure you follow all those guidelines, the guideline people give you, for example, the maybe the hygiene guideline, the safety guideline, all those stuff. Then when you're working on, be sure that you always refurbish your knowledge, whatever you study. For example, if you guys have attended the project management skill, it's very useful. Actually, it's very useful. You can still utilize it in the industry environment, even especially for a project firm environment. Then following by that, of course, to know how to read a P&ID is very, very useful tools when you want to understand a process, because there's 1,000 pipe inside a chemical industry process. So you have to understand how you're going to read a P&ID. And then, of course, the other one will be on your mass and energy balance, all those stuff lah. But I believe in the industrial placement, maybe you won't go so deep into that yet. But at least learn the safety culture. So as long as you are working as an engineer, safety culture is everywhere. So be used to it, learn it, adapt it. So I think this is the safety culture for firm people. So for people working in industry, even more important is on the safety, because your day-to-day time will be working in the factory. So you will deal with people from different class and different level. You will deal with people with like, for example, a team leader or a team operator, and you also deal with people from other cross department, which is not engineering background. And then you will deal with people from memory department. So first of all is you have to adapt those multicultural, and then adapt the safety environment, because for some of the plant, if they are quite big, they will have different process. Some of the process maybe is not so hazard. The hazard is not so hazardous, but some area can be very hazardous. So ensure that you follow their guideline, and then be aware of your situation, be alert, and observe as much as possible. So unlike firm, maybe you only have once or twice a chance to observe a real plant or go do site study. But in the factory, actually you observe those machines every day during your placement time. So be ensure that you observe those machines every day to see how they operate. Always ask. So in this stage, your most powerful tool is ask. Whatever question you don't know, you can ask. And then the more you ask, the more you gain, the more you learn before you graduated. So this is my advice to you guys.
Thank you very much. Any other questions from the floor, from students or even our lecturers? If no, no questions. So just a reminder, please make sure you sign in for today's attendance. I have put inside the group chat for you to sign up for your attendance for today. So please do so now. And then I think that in that case, we'll end our sessions today. Again, thank you very much, Vincent, for putting up your time to share with us with your industry experience.
So, no problem. Thank you.
Thank you, and have a nice day. Everyone stay safe until we meet again.
Thank you. Bye.
Bye-bye.